In this video we're going to have a very basic analysis of a data set related to healthcare expenditure in the Netherlands. So in the notebook I give you the web address where you can find these data, and then you can download them yourself. Here I'm going to cheat a bit because first of all I've copied already some code instead of typing it myself, because otherwise it's going to be taking a bit too long. I will explain what the code is doing, and then we start typing again to analyze the code. So first I'm importing this library URL lib, and the reason is because instead of downloading by hand and then using the data, I want to use this URL retrieve command, which first specifies, this is the part here, the web address of the data set that I'm using. It's a CSV file, comma separated file. So the first argument is this web address, and the second argument is where I want to save this data. In the notebook we analyze the data of both 2014 and 2011. In the screencast I'm going to focus on 2014. So I'll run the code, and in the meantime I will explain what's going on. One of the things that we want to do, because this is Dutch data, is to translate the columns that we're using into English. And the way to rename these columns in Pandas is to use a dictionary. So we have curly brackets here. And the format is the current name of the column. So that's the first bit. In this case that's Dutch. And then a colon, and then the new name of the column or variable, in this case the English translation. So geslacht becomes sex, leeftijdsklasse becomes age, etc. Yeah, so for all of the columns that we want to rename, we give the old column name first, then a colon, and then the new column name. And this is, in a dictionary, this is separated by commas. So we're going to use this dictionary in a second. Another thing that we want to do is to add a number of columns together, because as you can see in the notebook, what we're interested in is the effect of the deductible on healthcare expenditure. So then we need to add those cost categories that actually fall on the deductible in the Dutch system. So here we have a list of column names that are all columns that count towards your deductible in the Dutch healthcare system. We're going to read the file that we just created, the file that we recreated with this statement in the subdirectory data. We open this file, we use the pandas command read CSV, so we're going to read a comma separated file, except that if you actually open this file, it's not comma separated, it's separated by a semicolon. So we read this file, and we create a data frame df to contain the data in this file. So one final thing, so indeed if we go to this subdirectory that we specified here, the subdirectory data, I can see that indeed here we have this file for 2014. Yeah, so before I also downloaded the file for 2011, although I won't be using it in this screencast. So that we have this data frame, we can start doing things with it. So one thing we may want to do is to have this new variable health expenditure under deductible. Yeah, so I just specify the new variable name. So I'm going to add a column to my data frame, and this new column is called health expenditure under deductible, and it's going to be equal to the data frame, and from this data frame a number of columns. So cost categories under the deductible, the list that we just defined of columns that actually fall under the Dutch deductible, and I want to sum them. And I want to sum this across columns. So I specify the axis as being equal to 1. Yeah, remember, x is equal to 0 is rows, x is equal to 1 is columns. The second thing that we want to do is to actually rename the columns using the dictionary that we just created. So I'm gonna use this command rename. Here we have the dictionary columns to rename that I showed you a few seconds before. And again, we want to rename across columns, so axis is going to be equal to 1. There is one more renaming step that we want to do, and that's for our gender column. So we're going to replace here so because we use replace, we create again a dictionary. So the dataset uses V, which is Dutch, but we want to use F for female. And we're going to specify that we actually want to change this in the data frame itself, so in place is true. And now we can look what the data frame looks like, so we can do a head, but actually here I'm going to use a tail for a reason that I'm going to show you in a second. So here we have the last 5 rows of the data frame, and the thing I want you to notice is this sort of odd age variable 90 plus. Yeah, so we want to change that because 90 plus is not something that we can be working with. For instance, when we plot something with matplotlib. Yeah, so we can see here the renamed column names, hospital cares, pharmaceuticals, etc. We're not going to go through this completely, so let me make this a bit smaller. So let's create another cell. Another statement that's very useful is the drop statement in Pandas. So we can specify the columns that we no longer need. So there are actually a number of these, but I'll just give you a couple of examples. So one column that we're not going to be using is until. Yeah, so we're not going to be interested in this column, and we're also not going to be interested in this column. So we specify a list of columns and then ask Pandas to drop these. Again, we want to drop these in the data frame itself, so we use in place is true. And again, we want to drop these across columns, not across rows. We can change the type of variable, so we can say that the column for age should not be thought of, for instance, as a string, but it should be thought of as, so we specify as type, so we can say that it should be thought of as a categorical variable. Category. So it's a categorical variable. Later on we're going to change it to an integer. We cannot do that right away because we have this weird 90 plus. Where was it? Here. Yeah, so remember here we have 90 plus. So if I now ask Pandas to turn this into an integer, it will throw an error because it doesn't know what 90 plus is. So we first have to delete that. Another thing that we may want to do is to add a new variable, which are the costs per head. So the costs that are reported in the data file are the total cost for each postal code area, which is not what we may want to use. So we have health expenditure under the deductible. So this is total, so we want to divide this by the number of citizens that we have in a postal code. Instead of using the level of these costs, you may be interested in using the logarithm of these costs. So we can apply a function to it, so we get log costs per head. And then we're going to use from the NumPy library the function log, which gives you the natural logarithm. So to avoid taking the logarithm of 0, I add 1 to it, and this will then be the logarithm of 1 plus costs per head. Let me see where we are. Costs per head. So now let's get rid of this 90 plus thing. So I redefine the data frame as looking at all the rows in this data frame. And now I create a boolean where df h is not equal to 90 plus. And once we get rid of the 90 plus, then now we can say that we want to think of h actually as d of h as type integer. And now we can look at our data frame, the first 5 rows of the data frame. We got an error. So how do we deal with that? So when you get an error in Python, you first go to the final line of that error. So it gives me a key error, health expenditure under deductible. So I probably had a typo there. Health expenditure under deductible. It looks quite fine. So how did we define that? So here we created the variable health expenditure under deductible. Health expenditure. Health expenditure. It said heath expenditure. So that's why you get an error. So we try again and we get another error. Oh yeah, okay. So the reason why we get an error here is now I ran this code before. So I already dropped these 2 columns, and now I'm asking Pandas to drop them again. Well, these columns are no longer there, so I can actually comment these out because we've done that. I get a warning here about how I'm changing things in the data frame. We'll not worry about it for the moment. And now you can see that our h column is indeed consists of integers. So let's make this a bit smaller again. So the final thing we want to do here is to create a group by. So remember, in our data what you see is that we have for each postal code and each age and gender category healthcare expenditure. And basically I want to get rid of the postal codes. I simply want to average over postal code so that I get a data frame where I have for each age and gender category the average healthcare expenditure per head in that category. So what I'm going to do is I'm going to define a new data frame which consists of log costs per age. I'm going to use this function group by. And the thing I want to group by is age and sex. So I get basically I keep 2 columns. One is the age, the other one is the gender. And then the variable I'm going to be interested in is log costs per head. And the way we're going to aggregate is simply taking the average across postal codes. So I take the user function mean, and then finally I'm going to reset the index because it makes my data frame slightly easier to use. Actually, we may want to see what this looks like. So log cost per age. So now what I have is a data frame where for each gender, so female, male, and age, age0, and then female and male age1, etc., all the way to female and male age 89, I have the average log expenditure per head. So in the next video, we're gonna use this data frame to plot what these costs are, and we're gonna create a small model to analyze what's going on.